He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
I mean, some things we're pretty certain about. If we keep increasing greenhouse gases in the atmosphere, we're going to have a major melting in Antarctica, not just the sea ice, but the ice shelves and the ice sheets.
We like things the way they are, and they are already changing. So we're not going to like what we have in store for us.
I feel for people because there's just so much misinformation out there as well. Just with like any big topic that especially gets politicised, it becomes so difficult for people to understand what's actually happening.
Kia ora, nau mai haere mai. Hello and welcome back to Voice of the Sea Ice. I'm Claire Concannon. You know what kicked this whole series off? This.
Kia ora koutou katoa, nau mai haere mai. Welcome to this media briefing today.
It's the 3rd of October 2023 and the Science Media Centre have organised this briefing.
But mostly we're going to be hearing from Natalie Robinson.
Remember, we met Natalie in episode 3, looking for life amongst the platelet ice.
Although we might not have everyday experience of sea ice, there's a lot of services that sea ice provides that keeps our global climate system running the way we like it.
This chat with the media is part of an emergency summit involving around 50 New Zealand researchers who are sounding the alarm over the Antarctic sea ice winter maximum for 2023. It was a record low, following on from a record low summer minimum.
This has been essentially an alarming drop off the cliff, and we would like to think that it could be variability, but that would be the most optimistic outcome.
And this is the big question. Is this a blip or a rapid downward trend? And if sea ice is dropping off a cliff, what does that mean for Antarctica and what does that mean for us? We know the planet is warming due to our release of greenhouse gases. No matter what some people might say, the numbers on that are very, very, very clear. And you know, any kid with an ice cream will tell you that when it warms up, ice melts. But it's a little bit more complicated than that. We're going to get into this on different levels. First, the big picture, looking at sea ice extent. And then second, the land-fast sea ice in McMurdo Sound, where New Zealand researchers have been studying and where we've mostly been hanging out for the series. So first, big picture. Sea ice extent means the area of ocean where at least 15% of the surface is frozen. Since 1979, so for 47 years now, this has been measured in both the Arctic and Antarctica by satellites. Sensors on the satellites measure microwave energy coming from the Earth's surface, and sea ice in open water emit microwaves differently. So then you can figure out the sea ice extent in kilometres squared and create visualizations and nice curvy graphs. Curvy because, of course, sea ice goes through its yearly cycle. There's the maximum winter sea ice extent when it expands out to cover the biggest area, and then the minimum summer sea ice extent when it has contracted in towards the continent. The annual pulse, the heartbeat. And for quite some time, Antarctic sea ice seemed to be doing just fine. Even as the planet heated up and the Arctic sea ice started to rapidly disappear. Here's sea ice physicist Dr. Inge Smith.
When I was a very young PhD student, this was the thing that was just starting to happen. And so I was going to these conferences and watching these graphs being projected on the screen going, wow, this is like quite scary. It's suddenly declining rapidly. It's shrinking back from the coast in the Arctic, but it hadn't started to happen in Antarctica.
This was in the early 2000s, and the decline has continued since then.
Arctic is one of the fastest warming areas on the planet. Researchers say the Arctic has lost about half its sea ice since the 1980s. Now, thinner ice means even faster.
In fact, when people extrapolate backwards using marine sediment cores and historical records, things like ship logs and travel reports, it seems the decline in the Arctic sea ice began before the satellite records started, likely around the late 1950s. And it's not just the sea ice extent that has declined in the Arctic. There's also less and less multi-year ice, and the ice has gotten thinner. modelling in a paper published in December 2024 suggested that we might see our first summer day without any Arctic sea ice before 2030. And the decline in Arctic sea ice has enabled more access and open shipping routes, which in turn has led to this kind of thing.
That whole area is becoming very important, and for a lot of reasons, the routes are, very direct to Asia, to Russia. So we're going to have to make a deal on that.
Of course, the Arctic is completely different to Antarctica. Not just that it has the polar bears and 0 penguins, but because it is an ocean surrounded by land, whereas Antarctica is land surrounded by ocean. At the same time that young PhD student Inge was going to conferences and that Arctic sea ice decline was happening, Antarctic sea ice extent was holding steady. Or if anything, it was increasing by about 1% between 1979 and 2014. And there were, in fact, 3 satellite record highs for winter maximum sea ice extent in 2012, 2013 and 2014. But then,
in the last 10 years, suddenly there was a bit of a drop in the sea ice extent. It wasn't very much, but then in the last 2 years it's been much more dramatic, so it's like nothing that we'd ever seen.
And now you can actually make that 3 years. Inge and I spoke in November 2024. Since then, there's been another very low summer minimum sea ice extent. It was reached on the 1st of March 2025, and the sea ice covered just 1.98 million square kilometres. It's the 4th consecutive year that Antarctic sea ice has reached a minimum below 2 million square kilometres, while the average summer minimum across 3 decades of records is 2.84 million, which is a difference of 3.2 New Zealands. There are 3.2 New Zealand's worth of summer ice missing. But maybe it's making up for it in the winter, I hear you shout. Okay, maybe you're not shouting that, but I'll tell you anyway, it's not. 2023 was that lowest on record winter ice extent. September 2024, the most recent winter maximum, was the next lowest. 17.2 million square kilometres, which is 1.55 million square kilometres below the 30-year average, or 5.8 New Zealand's. But you know what? Antarctic sea ice is super variable. Some years there's more, some years there's less, and it can change a lot per region too. So maybe this is just a blip. And the shiniest of shiny optimists might believe that it is. But sea ice scientists just don't think so.
People are still investigating exactly why and what has caused that, but everyone agrees this has got to be some signal of climate change around the coast of Antarctica.
And while we won't know for sure until a few more years have passed, researchers have looked back in time and run the numbers, and to them, this looks like the start of a major regime shift. A change in the Antarctic sea ice cycle unlike anything we know of. But why wasn't Antarctica losing sea ice before this? Because the model said it should have been. Here's Dr. Natalie Robinson with one theory as to why.
As you might expect in a warming world, if you're getting warmer water in underneath the ice shelves, which are the floating extensions of the Antarctic ice sheet, then that could will increase the rate at which those ice shelves are melting. And that is then adding extra fresh water into the top of the ocean. The fresher the water is, the easier it will form sea ice. So that is one possible explanation as to why we had been seeing more sea ice formation. But now we've actually seen sea ice pass what appears to be some sort of threshold, because it's really plummeted. So from an oceanographer's perspective, that decline in sea ice is symptomatic of a warming ocean over a very large scale, which is pretty sobering when you think about how much energy it takes to heat up water and to heat up so much water when we're talking about the scale of the Southern Ocean.
The oceans have kind of been our buffer in this whole global warming thing. They've absorbed more than 90% of the heat energy we've created. A UN climate assessment tried to quantify this, and they worked out that between 1971 and 2018, the ocean gained an estimated 396 zettajoules of heat, which is gobbledygook to pretty much everyone. So they worked out the zettajoule energy equivalent in Hiroshima atomic bombs. It came to 25 billion bombs. So yeah, sobering is accurate, I would say.
We're now coming to the expectation that if sea ice were to recover, it would not be in the next decade. We're probably looking at least 10 years of low or declining further sea ice. And that's because we understand how much heat the ocean contains and how much more heat it has now than it did previously.
All right, so let's just get on board with this then. Let's be practical. This is our present and likely future. Antarctic sea ice is changing. What does this mean? Well, in episode 2, we learned about those important physical attributes of sea ice: whiteness, saltiness, and blanketness. If we've less sea ice, what happens then?
Sea ice is a lovely bright white surface, so it reflects solar radiation back to space rather than allowing it to be further absorbed into the ocean. And you can see that that is sort of a self-perpetuating mechanism. If you warm the ocean, you form less sea ice, and then that allows the ocean to warm more.
Ah, the old negative feedback loop. Less than ideal. As for the other two, well, less sea ice being formed means ocean currents will change, because there'll be less of that cold, dense, briny water. And without a blanket of winter sea ice, more heat will move from the relatively warmer ocean to the atmosphere during the dark, freezing months, which will alter weather patterns. One group looked at this for that super low 2023 winter extent. They focused in on regional sea areas in Antarctica where sea ice was the lowest. And in areas missing this winter ice blanket, they saw heat being lost from the ocean and observed an increase in storminess. And this change in Antarctic weather patterns is likely the thing we'll see in the short term, as the amount of floating pack ice reduces. What happens if we get less land-fast sea ice forming? Well, for that, we go back to episode 1 and Dr. Daniel Price.
The sea ice can act as a sort of shield at the front of the ice shelves, protect them from things like swell that's rolling in from the Southern Ocean and stop them from breaking out, essentially, or stop them from calving.
Now, this is a part of the normal process. Ice shelves are always flowing, the sea ice retreats in summer, big chunks fall off the ends, icebergs happen.
A lot of years here out the front of Scott Base, the sea ice will break out at the end of the summer. I mean, literally break up and over even hours just all disappear, so that this glistening ice-covered area that's out the front of base for most of the summer suddenly turns into open water. And then that leaves the ice shelf behind it vulnerable, and then typically hours or days after you'll see icebergs carve off and float away because they're no longer protected.
But if you've got less sea ice doing the buttressing, what will happen then?
We're looking at that by putting out stations on the sea ice and the ice shelf, and then at the end of the season, when the sea ice naturally breaks out anyway, we can look at how the ice shelf responds, how it speeds up. I guess the hypothesis there is that if fast ice areas start to decrease because the climate is warming, what are the knock-on effects then to the ice shelves behind them?
So far, so whatever, right? This is all ice that's floating in the ocean, so it's not going to contribute to sea level rise. But remember, feeding the ice shelves are the ice sheets. Those massive slabs of freshwater ice sitting on the Antarctic continent. And researchers have been studying the interaction of ice shelf and ice sheet, and when ice shelves lose ice faster at the edges or start to collapse, the flow of ice speeds up. meaning we then lose more of the ice sheet than can be replenished by new falling snow. And that definitely means sea level rise. That's why Daniel was making his crazy journey across the ice shelf in the first place, for a project that was looking back into the distant past to see what happened to the West Antarctic ice sheet, which feeds the Ross Ice Shelf, when the Earth was much hotter.
Looking to the past like this it's the key tool to predict what's going to happen in the future. So you can have this sort of paleoclimate effort, which is looking directly at what's happened in the past. Your contemporary scientific effort, which looks at observations in the real world now, and then you have the modelling, which looks to the future. And we use those three tools together to get the best understanding.
Recent climate modelling, led by Dr. Andrew Pauling, who works with Dr. Inga Smith, showed that the increase of cold freshwater from Antarctic ice sheet melt will partially counteract some of the impacts of warming that are coming New Zealand's way. So a slight silver lining? Though that's cold comfort for any of our coastal communities. All right, so we've got sea level rise happening now and more coming for us. And what about the penguins, I hear you ask? They also need land-fast sea ice. Surely you were asking that. Everyone is concerned about the penguins.
They are the iconic species of the Antarctic, but the question is for how much longer?
They hit the headlines in 2022 when a satellite study linked the low summer sea ice extent to trouble for 4 penguin colonies.
Emperor penguin colonies living in an area where there was total sea ice loss in 2022 have experienced almost total breeding failure.
This is because if the land-fast sea ice breaks up before the penguin chicks have got their waterproof feathers, it's really bad news. This happened west of the Antarctic Peninsula. And look, while this does sound awful, it unfortunately sometimes does just happen. With some colleagues, Dr. Michelle Leroux analysed satellite images for where you find emperor penguins around the whole of Antarctica. The sites differed between time of ice formation and how much the ice forms and breaks up. Though Michelle did find that bigger colonies tended to be in places with stable land-fast ice that only had small changes in its growth and retreat cycle. But what will the future look like?
We don't really know what's going to happen. And the reason we don't know that is because all of Antarctica, like the different regions in Antarctica, the oceanography is really different. So in some places, the pack ice will actually hold the fast ice in place. And so perhaps in places like that, if the pack ice goes away, perhaps the fast ice would as well. In other places, like here in the Ross Sea, if you look south of the Drgalski ice tongue, that holds the fast ice in place. And so it's possible, though I don't know this, it's possible that even if the pack ice in parts of the Ross Sea were to go away, that part of Antarctica may still have fast ice simply because the Drgalski ice tongue is functioning as kind of an anchor for a lot of that fast ice. So I think it's really variable, and it really depends where the emperor penguins are around Antarctica and what's going to happen to their habitat.
So if we've got a potential future with land-fast sea ice in some spots, but maybe not others, will the penguins move? Or are they creatures of habit that always return to breed where they were born, even if the ice becomes dodgy?
My professional opinion is that they do a little bit of both. So I think in places where emperor penguin colonies are in really good habitat, so they've got a lot of fast ice, the trend of the fast ice is increasing or it's growing slightly. If they've got a lot of food, why on earth would you go anywhere else? You know, you're kind of living it up, right? This is fantastic. But there are other places around Antarctica where the colonies are quite small and they seem to be in not very good habitat. This is the kind of habitat where the fast ice might break away a little bit too early sometimes, or it doesn't form at all. And the birds that had been there at that point, or at some point in the past, might show up and say, oh, this is no good, I'm going to try somewhere else, or I'm just not going to try this year at all. And so they both have the flexibility and also a little bit of what we would call philopatry, so that love of place and to be able to come back to that spot. So very long-winded way of saying I think they can do both, and I think they're very flexible.
All right, so at least in the short term, some of our flexible penguin friends might be able to find the best patches of land-fast sea ice. The modelling in the long term is not so good.
Predictions that with current warming trends, over 90% of emperor penguin colonies will be all but extinct by the end of the century.
But what about our favourite patch of landmass sea ice in McMurdo Sound? That's quite far south, so it's pretty cold around there. Maybe it'll be fine, at least for a while. Or maybe not. Here's Dr. Inga Smith again.
Initially, I'd kind of thought, well, global warming will hit here last. But then in 2019, there were some major storms in the middle of winter that kept blowing the ice out. So it never got to actually form properly that winter until quite late. So Greg Leonard was the lead author on a paper looking at that anomalous winter sea ice year.
Remember, we met Greg standing out on the March ice, taking a measurement of the sea ice thickness. As he explained that normally in that area of McMurdo Sound, the sea ice forms all around the same time. But in 2024, its formation was staggered, resulting in differently aged ice across the area. But the first time they saw something like that was in 2019.
We wrote a paper to the effect asking the question, is this an anomaly or is this the beginning of a larger change? And the observations we've had in subsequent years are hinting to the fact that it might be a longer change. So 2019, 2020, 2022, and 2024 are what we're calling abnormal years in that time frame. Although we're still seeing fluctuations, we're seeing some years in that time record which more look like typical years where the ice forms when we expect it to earlier in the winter season and remains through the whole time, but that's being interspersed more regularly now with these disrupted years where we're seeing those storm events and a very different formation process for the landfast sea ice.
The increased storms mess things up, just as the ice is forming.
So it's the high wind speeds and the wind drag on the landfast sea ice which are breaking that ice up in the winter time and blowing it out of the sound on a regular basis. And so that's very much atmospheric, wind-driven, much shorter timescales. But what we don't fully understand is the interrelationships between those processes that we're observing in McMurdo Sound and the wider changes we're seeing in pan-Antarctic sea ice.
This has impacts on logistics for those who need to set up field camps, such as Dr. Natalie Robinson.
The environment is changing, and it's changing faster than we can plan for and shift the way we do things. This is only on the scale of my scientific career, which is 20 years. It used to be easy to plan something of this size, and these last 5 years has really seen a shift in the conditions that we're being dealt and how we're having to deal with things on a daily basis. It's a different environment.
In staying with Natalie, how might the changing conditions impact the platelet ice and the life within it?
In the sort of short to intermediate term, we could actually expect to get more platelet ice because the Ross ice shelf would melt more, giving us more of that really cold water that you need to form platelet ice. But in the long-term future, if actually quite warm water gets in under the Ross ice shelf, that's the point where we would expect the platelet ice volume to start declining. But both of those scenarios have implications for how the ecosystem is going to operate.
Now, it's all very well talking data and uncertainty and observations and modelling with these scientists at what appears to be a time of unprecedented change for Antarctic sea ice. But I also wanted to know how they feel about it.
As a scientist, it's sort of interesting because we're racing to discover what's going on and what it means. But as a human and part of, the human race, I don't know what is in the future for us. But certainly we like things the way they are, and they are already changing. So we're not going to like what we have in store for us. That appreciation that we are overheating the planet has developed in the time that I've been a scientist. So when I first came down here, people were starting to appreciate the role that Antarctica plays in our climate, but we hadn't really got to the point of feeling alarmed. And so it was the opportunity for lots of discovery, just fascinating science. But over my time here and working within this community, really the time for being enchanted by the science is kind of gone for me. It's much more about the obligation to understand what on earth is going on, how fast it's happening, what the implications are for society as a whole, and making sure that I'm doing everything I can to help get that message out and make sure that people understand what our future is really turning into.
Working alongside Natalie are those like Dr. Jackie Stewart, who are just starting out in their career. At this time of extreme weather event headlines and increasingly urgent climate science reports, how does she feel?
There are days where it is like way too much, but I am really lucky in the sense that I am working in a job that I wake up and I'm doing work to try and help, or to help understand. Like, I'm not here solving the climate crisis, but I'm trying to understand how our world is going to react and what that might mean for nature and for us. And working in the space is a blessing and a curse, in the sense that you're working in the space and you're working to try and help it, but you're also exposed to it every single day. And thinking about that every day is sometimes not that healthy.
And Dr. Michelle Leroux?
It's really sad that we have done that, and that we have known that we were doing that. We could have done something a long time ago and we decided not to. And so that makes me really sad, but I choose to have hope and I choose to have optimism, and I want people to not give up. Honestly, like I think that sometimes people find that as like a platitude or just like a nice thing that scientists say, but I have never met a climate change scientist that says we're done. Like, I've never heard anyone say that. Like, and so this idea that, it's alarmism, it is absolutely not. And it's not alarmism, and it's also something that we still can have an impact on.
Scared, overwhelmed, sad, hopeful. Sounds about right. I feel these things too. But time to put the practical hats back on. What is the world doing about it? What is New Zealand doing about it? And is there a different way for us to talk and think about it so that we don't feel scared and overwhelmed?
There's lots of positive aspects to responding positively and boldly to climate disruption. Framing through those, what we call better life aspects, is a really helpful frame.
That's next on our last episode of Voice of the Sea Ice. Thanks to Dr. Inga Smith, Dr. Greg Leonard, Dr. Andrew Pauling, Dr. Natalie Robinson, Dr. Daniel Price, Dr. Michelle Leroux, and Dr. Jackie Stewart. Reporting for this series was supported by Antarctica New Zealand's Community Engagement Programme. Thanks to Megan Nicol for her help on the ice. Ellen Rikers and Liz Garton helped with production and editing. Sound mixing and design was by William Saunders, and there was additional sound design by Steve Burridge. I referenced a bunch of papers in this episode, and I will link them all at rnz.co.nz/OCW. Tēnā koe I whakarongo mai. Thank you so much for listening. I'm Claire Concannon. Have a great week. Kia pai, the wiki.